There are 4 steps in solving a parallel circuit. First step, solve the equivalent resistance. So that is the resistance if we replace all the resistors with one resistor. What value of resistance should that one be? That's called the equivalent resistance. Then find the current supplied by the battery using Ohm's law, V equals I times R. Then find the voltages for each resistor. They're the same as the voltage of the battery. And then also, the final step, find the current for each resistor, again using Ohm's law, V equals I times R. So in this circuit, we have 2 resistors, 6 ohms and 4 ohms. We have a battery that's 12 volts. We need to find the equivalent resistance, the current and voltage drop across each resistor and the battery. So the first step is to solve for the equivalent resistance of these 2 resistors. Now the question is, why don't you just buy one resistor in the first place that is the same as the equivalent resistance? And the reason is because if you go to a place like Radio Shack, they might not sell the resistance that you need. And so you have to buy whatever resistances they have and put them in the correct combination to get whatever resistance you want. So in this case, we have a 6 and a 4 ohm resistor, and the equivalent resistance is that we're going to add up the inverses of each resistor. And so 1/6 plus 1/4, we choose a common denominator of 12, we get 5 over 12. Now this is not the equivalent resistance. This is 1 over the equivalent resistance. So the equivalent resistance, we've got to flip this around. So this now becomes 12 over 5, or if you prefer, 2.4 ohms. So again, it's up to you if you want to keep things in fractions, if you want to put things in decimals. Make a decision, but I would stick with whatever decision you make. If you want to keep fractions, then keep it throughout all of them. And if you want to keep decimals, keep it throughout all of them. Now, to put this in your calculator, because there's a lot of mistakes that seem to happen when putting this in your calculator, the way that I would put this in my calculator is you just do 6 to the negative first, that just means 1 over 6, plus 4 to the negative first, again that just means 1 over 4. And if we do that, we get a certain value here. So let's actually put that into our calculator. 6 to the negative first plus 4 to the negative first, which is 0.416 repeating. Now that is not our equivalent resistance. What we have to do now is take 0.416 repeating to the negative first power. And if we do that, we get our 2.4. So just whatever your resistances are for a parallel circuit, add them with the negative first power, but that's not your answer. Take that answer to the negative first as well, and that's your equivalent resistance. So we have our equivalent resistance, which is 2.4 ohms, and now what we have to do is we have to next step solve for the current supplied by the battery. So the current is going to be found by saying V equals I times R, Ohm's law. So here we have 12 volts is equal to our current times 2.4 ohms. And so we get the current comes out to be 5 amperes. Now the next step in a parallel circuit is that all the voltages are the same. So the voltage of the battery is 12. This means that the voltage drop across the first resistor is also 12, and the voltage drop across the second resistor is also 12. They are all 12 volts. Now once you know 2 out of 3 values, you'll solve for the third value using Ohm's law. So we're going to solve for the current through the first and the current through the second resistor. So V equals I times R, we have 12 volts, is equal to our unknown I, times our resistance, which is 6 ohms. And we get the current through the first resistor as 2 amperes. Now we can solve for the current in the second resistor. Again, our voltage is 12 volts. we are finding our current, and our resistance is 4 ohms. And so we get the current through the second resistor to be 3 amperes. We see that the resistance is less, so the current is more. Now to check our work, we can use Kirchhoff's current law and apply it to a parallel circuit. It simply means that if we add the two currents in each resistor, 2 plus 3 gives us 5 amperes. It should equal the current of the battery itself, which in this case it does. One final thing I want to note here is that in a parallel circuit, when you're solving for the equivalent resistance has to be smaller than your smallest resistor. So in this case, our smallest resistor is 4 ohms. Our equivalent has to be less than that. And in this situation, again, it is. So it's another way to check your work. So to check your work, the equivalent resistance should be less than the smallest resistor in a parallel circuit. And the currents add together to equal the current supplied by the battery.